Okay, let's do another example. Let's right-click on source to create a new class. This will be our abstract class. The entire example will be created right in the source package. I'm not using the other packages here in this example. The name of the class will be animal, and make sure you check the abstract checkbox. That way the word abstract will be written for you. Animal abstract. Okay, and just hit finish after that. Don't check the public static void main. Private integer h. Oh, probably abstract void speak. So we have one abstract method. So any class that becomes a child of animal class will be required to write the body of this. Now let's create a new class, dog. And in the superclass type animal, we don't need to browse because they're in the same package. And make sure inherited abstract methods checkbox is checked, because what this will do, it will automatically write the body of speak for you. So you wouldn't have to worry about that. And here, that's the only thing I'm writing in the dog. That's it, the speak method. Now we will right click on source to create another class called spider as a child of animal. Again, make sure the inherited abstract method is checked, hit finish. And we're going to just display, I think that's the sound of spider, right? Let's put this to test now. Let's create a new class called demo animal with a public static void main. Right, I can only create null pointers, but not. Okay, so dog, I can create an instance, new dog. For spider, I can. And then I can use my dog instance to call, see, it can call the set age from the parent. Let's say 10. And s1 dot set age 1. d1 dot get age. Let me put here. Okay. Age is this, and the age is this. Okay. And then also do d1 dot speak and s1 dot speak. There you go. Now, it doesn't really, tell me age is of what, which animal, right? So I can do one more thing here. I can say the name of the object dot get class. Notice this method actually comes from object class, which is the grandparent of dog because it's a parent of animal. So you can say class dog age is 10, class spider age is 1. Now, guys, can I remove the word class from dog, like like before the word dog? Can I just remove the word class in a space? Absolutely. So I can just call dot If I do substring here, it doesn't understand. But I can convert it to a string first, then call substring and say I want to read everything from space 6 onwards, from character 6 onwards. So see, that's how I take care of that. Now what I'm about to show you is what we call dynamic polymorphism. Dynamic polymorphism means this is a polymorphic behavior, an on-changing behavior, but on the fly, not at the compile time. You guys remember that you can declare a null pointer of animal type, but not its instance? Now comes the question, what is the use of that null pointer? If we closely examine our classes like dog or spider, they're not really doing anything more than writing the body of an abstract method, which is overriding. So that means all the methods that they have are the ones that are already defined in the parent. They don't have any of their own methods, right? All the methods that they're working with are coming from the parent. So in this case, what you can do is you can actually make the animal point to the child. Replace all occurrences of D1 with ref, and the output will be exactly the same, no difference. So that's one of the benefits of dynamic polymorphism, that if child is only implementing the abstract method and has nothing new of its own, then you can use the parent variable or parent, I should say, null pointer to point to the child. So it can dynamically reference itself to the child type and then could then be used everywhere. Whenever it is used, it will refer to the dog's implementation of the method. Now let's shuffle these lines around a little bit. I will going to put all the dog related lines in one place and all the spider related lines in another place, just like this. Okay. This is how I'm doing it. Output will not change. It's just like I have categorized them like this. So this is my dog block and that's my spider block. Now, when you hit line number 13, from line number 13 onwards, are you using any ref line 13 onwards? And you'll be like, no, we stop using ref on line 11. So since you do not need dog to be referenced anymore, you can ask ref dynamically to now become spider because the dog is not needed anymore. So dynamically, you can change the reference to spider. So do you see the benefit of using, one of the benefits of using a dynamic polymorphism, that the same pointer can dynamically point to any of the instances of child type. So from this point onwards, if you ever see in Java a class X instance equals to new class Y, you'll be like, well, isn't it supposed to be class Y instance equals to new class Y? How can you have the name of the class different from the name of the constructor? Now you know under what situation you can do that. That you can take somebody of parent type and point at the constructor of a child. So this syntax will be only legitimate will only be allowed in the situation where a parent instance is pointing at a child constructor, but vice versa is not possible. You cannot say a child instance calling parent constructor. You can't do that because child is a parent type. Parent is not a child type. In a sense, like, a child is an offshoot of a parent. So in that perspective, like rose is a flower, car is a vehicle. So car is a child, rose is a child. So that's basically what it defines. So the backwards process is not doable. So anytime in Java you see a different class name than the constructor, the only possibility is the guy who's calling got to be a parent or an interface, which we'll talk about shortly. Now let's save it as demo animal 3. Oops, wrong one. Went to the wrong. Okay, so we'll save it as demo animal 3. Now let's say I have another instance of dog type like this, 815. So I just copy pasted lines 8 through 11 and just changed the age. That's about it. And you can test it to see that it works. Now there's a lot of repetition happening. And we will try to use the dynamic polymorphism to overcome the repetition. Well, to make that happen, I could create an array of animal. And I can say I need 3 items here. Okay? I can make the 1, 0 point at this guy, the 1 point at this guy, and the 2 point at this guy. And again, you're saying, well, you are repeating, right? Right? I am repeating anyway. So to even make it better, I will going to move these lines around. And let me loop through this process. So for integer I equals to 0, I should be less than ref.length I plus plus ref of I. Let me change this to ref of I. Yep, that fixed it. Okay, now let's go back to our example and let's go back to dog. Now, remember I told you that I created a spider and I created dog. There's one thing very different between the two under normal circumstances because people have different tastes. Typically, dogs are used as pets and spiders are not, right? At least my understanding is. So what we would like to do here is we would like to include some pet thing in dog. However, the thing is this, dog is not the only kind of an animal that could be a pet. There could be a cat, which could also be a pet. There could be other animals which could also be pets. So including something pet-like only in dog would have to force me to include that kind of stuff every time I have a pet class. And that way that class would be much larger than what it's supposed to be. I cannot add that functionality in the animal because not all animals are pets. So how can I solve this problem? Should I create another class and make that a parent class to dog? Can't do that because Java doesn't allow for multiple inheritance. Is everybody following what I'm saying here?
Yeah.
Okay. So the only way to solve this problem would be to create an interface. By definition, all methods in an interface are abstract. That's how the interfaces are. By definition, that's how they are. And I can then import, or I should say include, that interface in my class dog or any of the classes that need pet-like stuff, and then the interface will force them to write pet-like stuff. And Spider, not being a pet, will not going to import that interface, but everybody else will. So let's first create the interface. Let's first right-click on the source folder to create a new interface. And we're going to call this interface pet finish. Public abstract void. Everybody got this? Now let's go to dog. And in the dog, where we extends animal, we're going to say implements pet. Implements pet. Now hover over the dog, because after you write implements pet, it is asking you, well, there is a method in pet called play, which you never wrote the body for. So hover over dog and click on add unimplemented method. I'll just write sysout interactive play. Now let's create another class called cat, child of animal. Cat, child of animal. And in the line of interfaces, click add. And you will going to see a dialog box like this. Type here pet, and you will see the pet will show up as a package. Choose it, OK, and finish. So cat is the name of the class. Animal is the name of the superclass. Pet is the interface. So you have play and speak, both of them. So it's speak. And play. OK. Now let's create a new class called demo animal 4 with a public static void main. I can create animal ref equals to new dog, right? We have already seen that. However, what is the problem here? Do you see any problem? Do you see anywhere play in the list?
No.
No. The reason is that animal cannot see play. Where's play coming from? Pet. Dog can see play, but animal won't. So this is where you will not use the dynamic polymorphism, because dynamic polymorphism, the parent can only see those methods that it has or its parents have, but it cannot see anything that is specific to the child. So you will not use dynamic polymorphism. You will use dog instance. Now when you type, you can see play in the list. Okay. So now I can say d1 dot speak, d1 dot play. Similarly, I can say cat c1 equals to new cat and c1.speak and c1.play. Okay. Now, if you want to use animal to refer to dog, then you got to remember that you are limited to only using the methods that are available to you. Also, you can use pet to also create an instance of dog type. Remember, because it's also sort of kind of a parent, right? But if you do that, you will be limited to only calling those methods that are either from the object or from the pet, but not from the dog. So an interface or a parent class can be the null pointers, for a child type, but they have limitations. If you want full-blown access to everything, then you have to create an instance of child type. Now let's learn to create another kind of a constant. So we're going to create another interface. Sorry, we're going to just call it dog types. That's the name of my interface. Public static final string type 1. I should say type 1. Okay, is everybody done with this? Okay. Now let's go back to dog.java. And you can implement multiple interfaces. So I can say implement pet, comma, dog types. Okay, the reason I'm taking this approach, because I want to revise. It's been some time we have not revised the previous chapters, right? So let's do that. So if num is less than 1 or num is less than 6 or greater than 6, keep looping. Enter a number between 1 and 6. Num equals to new scanner dot x. Closing. Scanner system. Switch num case 1 sys out type types dot, and as you can see, it automatically can see all the types, right? So if I type here type 1, it knows type 1 without even reference because of implementing the interface. So as you can see here that I implemented more than one interfaces, pet and dog type. And once I implement an interface of dog types, it has just list of constants. However, I can just use that list of constants anytime I need to use that list anywhere in my project. And I am using it without any reference to the interface because it is as if I own it. Because all of them are public. Anybody who implement it will have access to all of them. Now let's put this to test. Let's go to demo animal 4 and let's ask D1 to make a call to this method. And the method that we just created in the dog was pick type, right? Oops, where's go? Here, okay. Dot pick type. So now when we call, it will ask for an input. If I enter a number outside of the bounds, it asks me again. It keeps asking me until I enter the correct output, and then it tells me the dog type is bulldog.